Welcome back to the Deep Dive. It is Friday, February 27, 2026. And frankly, if you have been glued to the news cycle this week like I have, you know that the tectonic plates of the automotive industry didn't just shift.
They completely snapped.
They snapped. We are looking at a landscape that is fundamentally different than it was just 7 days ago.
It really is a historical week. I don't use that phrase lightly either. We are going to look back at late February 2026 as a distinct before and after point in industrial history.
Yeah.
It's up there with the introduction of the moving assembly line by Ford.
Absolutely. Because the headlines are screaming one thing, but the implications are whispering something much darker and honestly more fascinating. The headline, of course, is that Tesla has officially confirmed the discontinuation of the Model S and the Model X.
The cars that literally started it all.
The cars that started it all. I mean, the Model S was the car that proved an EV didn't have to be a glorified golf cart. It made electric vehicles cool. And now it's just dead.
It is. And the Model X, too, the whole spaceship vibe with the Falcon Wing doors, it's going out with it. But you're right, the retirement of the cars is just the symptom here. The cause is what we really need to chew on today for our listeners.
Exactly. This isn't just about retiring old models because sales are getting a bit slow. This is a burn the boats moment.
A total point of no return.
Right. Elon Musk isn't just closing a production line. He is gutting the Fremont factory, which is basically hallowed ground in the EV world, to convert that massive square footage into a production hub for the Optimus Gen 3 humanoid robot.
It's a massive pivot.
Yeah.
We're talking about swapping out wheels for legs.
Yeah.
And not just as a side project or an R&D thing. They are betting the entire company on it.
So today, our mission for this deep dive is to unpack this entirely. We are going to look at the state of the humanoid robot race right now in early 2026.
Because it is a race now.
It is a full sprint. We need to figure out why a car company would kill its flagship products, its halo cars, for a robot that, let's be honest, 2 years ago was a guy in a spandex suit dancing on a stage.
It has come a very long way since the spandex suit days.
It has.
The tech stack involved now is completely unrecognizable compared to that initial reveal.
It certainly is. And we aren't just talking about Tesla today either. We have to look at the competition because this isn't a one-horse race.
Not at all.
We have Boston Dynamics finally commercializing, Figure AI exploding in valuation, and a massive wave of Chinese innovators who are arguably moving even faster and definitely cheaper.
The Chinese market is moving at a scary pace.
It really is. So we have a big stack of sources here for you today. We're pulling from Q4 2025 earnings calls, technical breakdowns of the new end-to-end neural nets, some ground reports from CES 2026, which just wrapped up last month, and manufacturing updates directly from the factory floors.
Sources this week are really dense, which is great for us. We have dry technical white papers mixed with sheer financial panic.
My favorite combination.
It's the best.
So let's dive right into the news that dropped during that Q4 2025 earnings call. Musk called the end of the Model S and X an honorable discharge.
Right. That's a very specific, very Muskian choice of words.
It is.
Honorable discharge. It implies a soldier completing a tour of duty. Yeah. And in a way, he's right. These vehicles fought the initial war against the internal combustion engine.
They took all the early hits.
Exactly. They established Tesla as a luxury brand when literally everyone thought they were vaporware. They funded the development of the Model 3 and the Model Y, and now they're being allowed to retire with dignity.
But let's pause on that dignity thing for a second, because if you want one, the clock is ticking right now. Production winds down officially in Q2 of this year, 2026.
Correct. If you have been holding out for a brand new plaid Model S, which is still, by the way, one of the fastest production cars ever made, you basically need to order it today. The order books are closing fast.
But I do want to push back on the honorable narrative just a bit, because looking at the financial context you highlighted in the source notes, this feels less like a victory lap and more like a harsh necessity.
It definitely was forced by the math.
Yeah, Tesla's revenue actually dipped in late 2025. It was the first annual revenue decline on record for them.
That context is crucial for you to understand this move. You cannot divorce this robotic pivot from the balance sheet.
No.
If you look at the delivery numbers for Q4 2025, the Model S, the Model X, and the Cybertruck combined, all of their high-end complex vehicles, They only made up about 3% of their total deliveries.
Only 3%. That is startlingly low for the flagship tier.
It is. The vast majority of their volume and their cash flow is still the Model 3 and the Model Y.
Right.
So from a cold, hard business perspective, the S and X were becoming legacy artifacts. They're incredibly expensive to build. They require a lot more manual labor compared to the newer automated lines. They take up a massive factory footprint. And frankly, they aren't driving the growth narrative anymore.
Wall Street doesn't care about a steady 50,000 units a year of a luxury sedan.
Exactly. Wall Street cares about the next big thing. They want exponential growth.
So Musk is looking at that factory space in Fremont. And we know Fremont is incredibly space constrained. It's not like Giga Texas, where they have endless land to just build another shed.
No, Fremont is landlocked in California.
Right. So he's thinking, I can do something much better with this square footage.
This is the classic innovator's dilemma playing out in real time.
How so?
Well, usually companies wait way too long to kill their cash cows or their halo products.
Right.
They wait until the product is actually losing money before they pull the plug.
Oh, I see.
Musk is killing them while they are still profitable but declining. He's doing it to force the entire organization to focus on the future.
But consider the actual logistics of this. Ripping out an automotive assembly line isn't like rearranging the furniture in your living room.
Oh, it's a total nightmare. We are talking about massive standing presses, the body-in-white lines, the painting robots that are programmed specifically for those exact chassis.
They have to rip all of that out.
All of it, down to the concrete.
And the supplier contracts. You have Tier 1 suppliers who have binding contracts to deliver suspension arms for the Model S for another 2 years.
Right.
Tesla is likely paying massive kill fees to break those supply chains.
Billions of dollars likely in cancellation fees alone. It's a very capital-intensive demolition. But the goal is explicit. They are stripping out the vehicle assembly lines to install production lines for Optimus.
And the target capacity is what really scares people.
It's wild.
They are targeting a capacity of 1 million units per year. 1 million humanoid robots a year. That number just sounds, well, it sounds like sci-fi. It sounds like Isaac Asimov.
It does sound made up, but we have to ground this in the reality of what actually happened on January 25, 2026. That is a date you really should mark down.
What makes January 21st the turning point?
Tesla confirmed that mass production of Optimus Gen 3 actually began on that day.
So we aren't talking about prototypes in a lab playing around anymore?
No.
This is a manufactured product rolling off an assembly line.
Correct. It is no longer a science project. It is a product. And that distinction is vital. When you move from prototype to mass production, you enter what Musk famously calls production hell.
Right, we remember the Model 3 production hell.
Exactly.
Yeah.
But it also means you are fully committed. You don't start mass production unless you think you have a final design that works.
You definitely don't build custom tooling for 1 million units if you're still figuring out how the thumb joint is supposed to bend.
Exactly.
And the financial gamble here is just wild. Musk claimed on the earnings call that Optimus could eventually reach a valuation in the tens of trillions. Not billions, trillions.
He genuinely believes it will eclipse the car business entirely. And frankly, Wall Street is split right down the middle on this. You have the skeptics who look at the timeline, and we know Tesla has a notorious history of being very optimistic with dates.
Very optimistic.
Right. And they're worried about the revenue gap.
Yeah.
You just killed the S and X. Your overall revenue is dipping. And the robots aren't sold in high volume yet to make up the difference.
That is the classic valley of death that investors are terrified of.
It is.
But what about the other side? The believers.
The other side just sees the math.
Yeah.
If you can build a robot for $20,000 that can replace or even just augment labor worth $50,000 a year,
Yeah.
and you can sell 1 million of them, the margin potential is unlike anything in hardware history. It basically becomes software-like margins on a hardware product.
Well, if they are going to sell 1 million of these things to businesses, the robot better be really good. Let's unpack the Optimus Gen 3 itself from the technical sources.
Let's do it.
Because looking at the spec sheets we've got here, this isn't just a software tweak. This is a massive physical leap from the Gen 2 we saw videos of last year.
It is a complete overhaul. Let's start with the body, the hardware itself. The most critical upgrade by far is the hands.
The hands? I saw the video of it playing the piano, right?
Yes. The Gen 2.5 and now the final Gen 3 hands have 22 degrees of freedom. The previous generation only had 11.
So for you listening who isn't a roboticist, why is 22 the magic number here?
Think of degrees of freedom as the number of distinct ways a joint or mechanism can move independently. Your human hand has roughly 27 degrees of freedom.
Okay.
So getting to 22 means the robot can do almost everything a real human hand can do. It can articulate the thumb perfectly, curl the fingers independently, spread the palm wide, and pinch with extreme precision.
So it's not just opening and closing a rigid claw like old factory robots.
Far from it. We aren't just talking about grasping a box. This is fine dexterity. And the big breakthrough here is the actuator density.
What does that mean exactly?
In the old days, to get that kind of finger movement, you needed bulky motors up in the forearm of the robot and cables running down to the fingers, pulling them like tendons.
Which causes a lot of friction, right?
Friction, stretching, and physical lag. It's called hysteresis in engineering. You pull the cable, and there's a tiny split second before the finger actually moves.
Which ruins fine motor control.
Exactly. With Gen 3, they have managed to miniaturize the actuators to fit completely inside the hand and the wrist itself. It's all direct drive now.
Wow. And that is what allows for the tactile sensing we read about in the CES reports.
Precisely. The fingertips on the Gen 3 have specialized sensors that can detect pressure, texture, and crucially, slippage in real time.
Describe the slippage scenario for us, because reading about that felt very distinctly human to me.
Imagine you're holding a raw egg. If it starts to slide down due to gravity, your skin feels the friction change instantly.
Right.
Your brain tells your fingers to tighten just a microscopic fraction,
Sure.
enough to stop the slide, but obviously not enough to crush the thin shell.
Yeah, because if you squeeze too hard, you have a mess.
Exactly. That feedback loop happens in milliseconds in humans. Optimus can now do that natively. That micro adjustment is literally the difference between a useful home robot and a clumsy machine that breaks every glass in your kitchen.
And on the flip side of holding delicate eggs, the source notes mention it can do kung fu.
Yeah, that was the demo that caught everyone's attention on social media. But the kung fu moves, the high kicks, the one-legged balance, they aren't just for show or marketing.
What do they actually prove?
They demonstrate the speed and responsiveness of the actuators. It shows that the robot can move its center of mass rapidly without falling over.
Which really matters for walking right, because it can actually run now.
A real run, not a fast shuffle. It uses a heel-to-toe gait that mimics human biomechanics perfectly. It's actually pushing off the toe.
Why is that a big deal compared to how robots used to walk?
Old robots used a bent-knee robotic stomp to keep their center of gravity low and stable. This new gait is important because it means the robot can move through a facility at a human speed.
Ah, I see.
If you have a robot that safely shuffles along at half a mile per hour, it's a bottleneck in a busy factory. If it can jog at 5 miles per hour, it flows naturally with the human workforce.
One detail that really stood out to me in these reports was the self-sufficiency aspect. This feels like the final piece of the puzzle for a true 24/7 labor force.
This is huge for real-world autonomy. They introduced a new autonomous charging pad for Gen 3.
Because previously, a human had to plug the robot in, right?
Yes. Or it had to dock in a very specific, rigid, mechanical way that often failed. Now, Optimus can identify the charger across the room using its vision system, walk over, and align itself.
Even if the pad was kicked or is slightly askew?
Even if it's askew, it uses vision to line up the pins and top up its battery without any human intervention at all.
So it can essentially work a shift, realize its battery is hitting 10%, go charge itself, and just go right back to work.
Exactly. It enables the true lights-out factory concept. You don't need a human babysitter walking around to plug the workforce in at night.
But you know, all this hardware, the 22 degrees of freedom hands, the running legs, the battery management, it's totally useless without the brain.
It's just an expensive statue without the software.
Right. And this is where I think the biggest foundational shift has happened in the last 12 months.
I agree completely. The hardware is incredibly impressive engineering, but the software is the actual miracle here.
We keep hearing about end-to-end neural networks in the sources. We hear these buzzwords a lot in AI generally, but what does it actually mean in the physical context of a robot moving through a room?
So traditionally, robotics coding was very deterministic. It was heuristic-based.
Meaning if-then statements.
Right. You would write rigid code that said, if the camera sees a cluster of red pixels in this quadrant, identify it as a box.
Yeah.
Then calculate the distance. Then move the arm 20 centimeters to the right. Then close the gripper.
It was a very literal recipe.
Very rigid recipe. And it was incredibly brittle. If the lighting in the factory changed and the box looked pink instead of red, the robot failed. If the box was turned sideways, the robot failed.
Because the code didn't explicitly account for sideways pink boxes.
Exactly. You had to account for every single variable in the code manually.
And Tesla just scrapped that entirely.
They did. They threw it out. They are using a pure end-to-end neural net. This means the input is raw video data from the cameras, just raw pixels. And the output is the direct action controls for the physical actuators.
Wow.
There is no middleman of code saying identify object or calculate distance. The AI just looks and acts simultaneously.
It feels like intuition almost. Like when I drive a car, I don't calculate the specific geometric angle of the steering wheel. I just turn it until the car goes where I want.
It mimics human intuition perfectly. It's what we call a vision language action model, or VLA, though Tesla has their own proprietary architecture for it.
And the way they trained it is fascinating. They call it the YouTube training hack in the papers.
I love this part.
It sounds like something a teenager would do to learn how to fix a sink. They're just having the robot watch YouTube.
Basically, yes. They scraped millions of videos of humans doing real tasks. Cooking, cleaning, factory work, fixing cars, whatever they could find.
But they aren't just watching the video for the gist of it.
No, the system analyzes human movement, frame by frame. It's specifically looking for micro-adjustments.
Give me an example of a micro-adjustment that a traditional computer program would usually miss.
Think about pouring a cup of coffee.
Okay.
When you pour coffee from a full pot, as the pot gets lighter, your wrist automatically adjusts the angle slightly to keep the stream of liquid steady.
Because the center of gravity of the pot is shifting as the coffee leaves.
Right. You don't consciously think about it, it's just muscle memory. But the physics of the object change drastically as the liquid leaves.
Right.
The AI watches millions of pours across thousands of videos and learns, oh, when the pot looks like this and the liquid flow looks like that, the human wrist stabilizes like this.
That is wild.
It literally learns the physics of the real world through visual observation.
So it learns the feeling of the task by watching it happen. But there has to be a limitation there, right? I mean, watching a video of a coffee pot doesn't actually tell you how heavy the pot is.
That's the main challenge. And that's exactly where the teleoperation comes in to bridge the gap.
The VR suits.
Yes. Tesla employs humans wearing full VR suits and haptic feedback gloves to perform these specific tasks on the physical robot. The robot feels the weight and the resistance through the human operator, records that precise motor data, and combines it with the visual video data.
And then once it has the basic idea of the task from the human, they use simulation training.
Yes.
This sounded like the Matrix for robots to me.
That is the best analogy for it. One single robot learns a task in the real world, say it's folding a t-shirt.
Okay.
Then they upload that successful data to a massive digital simulation where thousands of virtual Optimus robots practice that exact task millions of times overnight.
Millions of times.
And they introduce endless variables in the simulation. They change the lighting, they change the shirt color, they make the table slippery, they add wind.
Accelerating learning by years in a single night.
Exactly. It creates a massive flywheel effect. The software improves exponentially faster than the physical hardware ever could.
Speaking of the physical hardware, before we move on to the competitors, we should touch on the material science briefly, because you mentioned in the pre-show notes that they aren't using standard off-the-shelf parts to build the skeleton.
No, they can't.
Yeah.
To make it light enough to be safe around humans, but strong enough to do industrial work, they're using custom aluminum magnesium alloys.
So it's light like plastic, but strong like steel.
Roughly, yes.
Yeah.
But the really cool engineering part is the thermal management.
The cooling system.
Right. If you have a robot doing squats or carrying 50-pound boxes all day long, those electric motors get incredibly hot.
Sure.
And if they get too hot, they automatically shut down to protect themselves from melting. Tesla actually built liquid cooling channels directly into the metal skeleton.
Like a biological circulatory system with veins.
Exactly like that. The coolant flows through the actual bones of the robot directly to the actuators. This allows them to run the motors at absolute peak performance for much longer without overheating.
Which is a trick they learned from the cars, right?
Yeah, it's a direct carryover from the thermal management in the Model 3 battery packs.
Okay, so Tesla is clearly going all in, but they are definitely not the only ones in the ring right now. We have to talk about the heavyweight challenger, Boston Dynamics.
We do.
I feel like we've been watching their robots dance and do parkour on YouTube for a decade, but something fundamental changed this year.
The biggest change was the retirement of the hydraulic Atlas model.
You mean the big, bulky, loud robot that did the backflips?
Yes. That was primarily a research platform. It was hydraulic, meaning it used pressurized fluid pushing through tubes to move its limbs.
The one that sounded like a lawnmower and had that massive backpack?
Exactly. It was incredibly strong, but it was leaky, it was loud, and it was very heavy. That model was fully retired, and in its place, they finally launched the fully electric commercial Atlas.
And it is really sleek looking.
Very sleek. In fact, it won Best Robot at CES 2026 just last month.
And this electric version isn't just a research project anymore either, right?
No production officially started in January 2026 at their Boston headquarters. This is a real commercial product now.
Wow.
And the big advantage they have, which people often forget when comparing them to Tesla, is their parent company, Hyundai.
Right. I always forget Hyundai actually owns them now. I still think of them as that scrappy MIT spinoff.
Hyundai bought them a few years back, and that is a massive strategic advantage right now in 2026. Hyundai is deploying Atlas into its robot meta plant in Georgia.
But more importantly, it's about the parts, right?
Yes. Boston Dynamics doesn't have to build a supply chain from scratch like Tesla might have to for certain specific robot parts. They're using Hyundai Mobis, which is this massive existing automotive parts network, to build the robot actuators at scale.
That's incredibly smart. You just use the existing car parts supply chain to build the robot parts. It brings the unit cost down immediately.
It reduces costs dramatically and increases reliability. Hyundai already knows how to build millions of electric motors that don't break down. But the other partnership that is absolutely fascinating with Boston Dynamics is with Google DeepMind.
So Hyundai builds the body and Google builds the brain.
That's the pitch. They are integrating Google's Gemini robotics foundation models directly into Atlas.
How is that practically different from what Tesla is doing with their end-to-end network?
Well, Tesla is building a brain specifically trained for physical robot tasks. Google is taking its massive general-purpose large language model, the LLM, the thing that powers text chatbots, and basically giving it eyes and arms.
Going what?
The goal is a truly general-purpose brain that understands human context.
Meaning what in a real-world scenario?
Meaning you could tell the Atlas, hey, I spilled my soda, clean it up. The Google brain understands that the concept of clean it up implies finding a cloth, wiping the liquid, and throwing the wet cloth in the laundry or trash.
It understands the sequence of concepts.
Right. It understands the concept of cleaning. Tesla's approach is currently more about direct physical imitation of a task. Google's approach is more about deep semantic understanding of the world.
That is a formidable combination. You have the search giant's AI and the car giant's manufacturing base.
It is the main counterweight to Tesla's vertical integration model. Tesla tries to do everything entirely in-house. Boston Dynamics is partnering with the best massive player in each distinct field.
So we have the two giants battling it out, but then there is the broader commercial race, the companies that are actually working and deployed right now.
The ones moving boxes today.
Exactly. Let's talk about Figure AI. Their valuation explosion recently is hard to ignore, but I have to be the skeptic here for a minute.
Go for it.
They went from a $2.6 billion valuation to $39 billion in just 18 months.
It's a staggering jump.
It feels very bubbly. That feels like the 2021 tech boom all over again.
Yeah.
And they haven't shipped a mass consumer product yet.
It is historic and it is a bit frothy. I won't deny that at all. But you have to look closely at who is actually writing those checks.
It's not just random venture capitalists.
No. It's Microsoft, it's NVIDIA, it's Jeff Bezos. They are pouring money in because they see Figure's Helix pivot as a potential monopoly play.
Explain the Helix pivot for us, because they made massive headlines for basically breaking up with OpenAI.
They did. In early 2025, they terminated their very publicized partnership with OpenAI. The CEO, Brett Adcock, realized that if you are just building a physical body for OpenAI's brain, you are ultimately just a commodity hardware maker.
Like Dell making PCs for Windows.
Exactly. To really own the robotics market and the massive margins, you have to own the brain.
Yeah.
So they abruptly shifted and built their own vision language action model called Helix.
But is it actually working? I mean, Brett Adcock basically said, I can build a better robot brain than Sam Altman. That's a bold claim to make.
It is incredibly bold. The proof is supposed to be happening right now at the BMW Spartanburg plant. They have Figure O2 robots actively working on the line there.
Now, I read the industry reports on that BMW deployment, and the initial word leaking out was that it was pretty underwhelming.
It was definitely overhyped initially. The robots were moving very slowly. They had a lot of trouble with edge cases on the line. But over the last year, reports indicate their performance improved 400%.
What are they actually doing at BMW?
They are inserting sheet metal parts precisely into the chassis.
But that's a brownfield application.
Exactly. And that's the absolute hardest place to put a humanoid robot.
Explain brownfield for the listener quickly.
Brownfield means an existing legacy factory that is full of human workers, weird variable lighting, and narrow aisles.
It's not a pristine, perfectly mapped clean room.
Right. The fact that Figure 02 is operating there reliably now is a very big deal. However, I completely share your skepticism on the $39 billion on valuation. That price tag implies they were going to win the whole market. And as we've seen today, the field is incredibly crowded.
And they just announced the Figure 03 late last year, right?
Yes. And Figure 03 is specifically designed for both mass manufacturing and home use. That is the next massive frontier they are actively eyeing.
But if we are talking about robots doing real work today, not tomorrow, not in a flashy demo, but physically moving boxes right now, we have to mention agility robotics.
The pragmatists.
They really seem to be the pragmatists of the bunch.
They are. Their main robot, Digit, doesn't look human at all.
No, it's quite strange looking.
It had those ostrich legs, the backward bending knees. It doesn't have a friendly human face. It just has a weird glowing sensor array for a head because it has one specific purpose, moving totes.
Right. It's not trying to play the piano or do a backflip. It's not trying to gently fold your laundry.
No, it picks up a standard industrial tote, walks it over to a belt, and puts it down. But because it is so highly specialized for that one task, it is already deployed at scale. Amazon and GXO Logistics are heavily using them.
Didn't they just hit a massive milestone?
Yeah, they hit a milestone of moving 100,000 totes at a single GXO facility.
And the economics there are really interesting to me because they aren't actually selling the robot to GXO, right?
No, they use a robot as a service model, or RAISE. Companies don't drop $100,000 on capital hardware. They just subscribe to the labor itself.
So they pay an hourly rate for the robot.
Yes. The operating cost comes out to roughly $10 to $12 an hour.
Compared to human labor at what, $30 an hour with benefits?
Exactly. When you present a logistics CFO with that math, $12 versus $30. And the $12 worker doesn't take bathroom breaks, doesn't get a bad back, doesn't need expensive health insurance, and will happily work a double shift in the dark.
The adoption just becomes a spreadsheet decision. It's not a philosophical debate anymore.
It's pure math at that point.
But agility success raises a really deep philosophical question for me. Do we actually need a human-shaped robot at all?
That is the core debate in the industry right now. Tesla and Figure say yes, absolutely, because the entire human world is built for the human form factor.
Stairs, door handles, hand tools.
Exactly. They're all designed for our hands and our legs. So the ultimate robot should match the world it works in.
And agility's counter-argument.
Agility says just build a robot that is exceptionally good at moving boxes. Who cares if it has knees that bend backward if it gets the job done cheaper?
That perfectly brings us to the elephant in the room, price. Tesla is targeting a price point that frankly seems completely impossible compared to the others.
This is the price war segment of our discussion. Musk wants Optimus to cost between $20,000 and $30,000.
He explicitly wants it cheaper than a car.
Right.
Which honestly makes sense if he is building it in a literal car factory using repurposed car parts.
It does make sense from a scaling perspective. But look at the competitors. The Boston Dynamics Atlas is estimated to cost around $140,000 to $150,000 per unit.
Wow.
Figure AI is a pure subscription model of about $1,000 a month, plus hefty setup fees. Tesla is aggressively trying to commoditize the hardware in a way literally no one else is attempting.
But there is one group that might actually beat Tesla on price. And honestly, this is the part of the research that kept me up last night. The Chinese manufacturers.
The China factor cannot be overstated here. We focus so much on Silicon Valley and Austin, but China is sprinting right now.
Let's talk about Unitree. They launched the G1.
And it is available right now in 2026. You can buy it today.
And the price?
$13,500 to $16,000 depending on the exact specs.
That's the price of a used Honda Civic. That's the price of a mid-tier motorcycle for a highly capable humanoid robot.
It is. And it's not cheap junk either. It's incredibly capable. It can jump 1.4 meters high, which is actually higher than its own standing height.
That's terrifying.
It's extremely agile. There are videos of it carefully cracking walnuts with its hands.
How? Wow. How are they doing it for $13,000 when Boston Dynamics is sitting at 150 grand?
Massive, unprecedented supply chain integration. The Shenzhen hardware ecosystem is completely unbeatable for cheap, reliable electric motors and battery cells.
Right.
And frankly, there's just fierce domestic competition driving margins to zero. But there's also the heavy hand of the government.
Of course.
The Chinese Ministry of Industry and Information Technology, the MIIT, set a formal national goal for mass robot production by 2025 and total global market dominance by 2027.
So this is a heavily state-backed directive. It's not just startups competing.
Effectively, yes. They view humanoid robots exactly the way they viewed the EV market 10 years ago. They dominated batteries, they dominated global solar panels, and now they explicitly want to dominate embodied AI.
And it's not just Unitree leading this charge. XPeng, which is another massive EV company, very similar to Tesla's model, is already mass-producing their Iron Robot.
The Iron Robot is fascinating technically,
Right.
but we really have to touch on the massive controversy there.
You mean the Iron Female?
Yes.
I saw those videos. The catwalk gait. It was deeply unsettling.
Yes, it was. XPeng released a specific model with a very intentionally designed female aesthetic. Curved waist, specific chest proportions, and a walking gait that exactly mimicked a fashion model on a runway.
It sparked a massive online debate about the uncanny valley and objectification.
It did. It felt a little too real, a little too human for people. A lot of critics felt it was entirely gratuitous and weird.
I understand that reaction completely.
But from a pure engineering standpoint, we have to look past the questionable aesthetic choice for a second.
What does it show technically?
To make a heavy, bipedal robot walk with that kind of specific fluid style, swaying the hips, placing one foot directly in front of the other on a narrow line rather than a wide robotic stomp, that shows an incredible mastery of the actuators and balance.
It shows they have total granular control over the dynamic motion planning.
Exactly. Whether you hate the design or not, the underlying tech required to make it walk smoothly like a supermodel is vastly harder than making it walk like a stiff soldier.
And beyond that controversy, they are deploying these at real scale in China, right?
Oh yeah, companies like Agibot and UB Tech are deploying thousands of commercial units right now. They have fully autonomous battery swapping stations, so the robots literally work 24/7.
They are just flooding the industrial zones.
They are flooding the Pearl River Delta with robot labor.
So we have these massive factories filling up with $13,000 robots. But what about our homes? You mentioned Figure is looking at it, but there is another player in the sources, 1X, that is taking a very different approach to domestic safety.
1X is a really interesting Norwegian company, heavily backed by OpenAI actually. Their home robot is called Neo.
Okay.
And their core philosophy is this. If a robot is going to be in your living room, walking near your kids or your pets, it cannot be a rigid metal machine that could accidentally crush a bone.
Because if a heavy hydraulic robot bumps you, you break.
Right. Or even a gear-driven robot like Tesla's Optimus. If a software glitch happens and it rapidly swings its metal arm, it's basically a sledgehammer.
So how does 1X actually fix that physical danger?
Soft robotics.
Off robotics.
Yeah, they use specialized tendon-driven actuators. It physically mimics biological muscles rather than using hard metal gears. It's explicitly designed to be safe to touch.
So it's squishy.
Kind of. It's compliant. If it bumps into you, the limb gives way naturally, just like a person would if they bumped into you in the hallway.
And are they actually selling these Neo robots to people?
Pre-orders are officially open for 2026 home delivery. They are marketing it very specifically for tedious household chores. Folding the laundry, tidying up toys, basic cleaning.
That sounds absolutely amazing because I hate folding laundry. But also, it sounds slightly terrifying. I mean, let's talk about the real risks here. Hacking has to be number one.
This is the massive security question of the decade.
If you have a highly capable robot in your house, it has cameras mapping your floor plan, microphones listening to your conversations, and the physical strength to lift 50 pounds. And it's connected to the internet.
Right.
Can it be hacked?
Yeah.
Can someone malicious take physical control of it remotely?
Well, Tesla strongly argues their processing is entirely local.
Meaning what for the user?
Tesla emphasizes local processing chips and end-to-end encryption. The idea is that the raw video data and the decisions don't ever leave the physical robot or your local home network. It's not pinging a cloud server to decide how to fold a shirt.
But as with literally any connected device, your baby monitor, your smart fridge, the risk is never zero.
Exactly. And the consequences of a hacked smart fridge is that you get spoiled milk. The consequences of a hacked humanoid robot in your kitchen are physical and potentially lethal.
And then there's just the inherent physical safety of the machine failing. Optimus weighs 125 pounds. It's dense metal.
This is why strict safety protocols are critical. Force limiting, meaning the robot instantly detects unexpected resistance and freezes completely, and advanced collision detection are totally non-negotiable for home use.
Which is why the soft robotics approach of 1X is so compelling to some families over a Tesla.
Exactly. It puts the safety directly in the physics of the machine itself, not just relying on the software to not crash. Even if the NEO software totally crashes and it falls on you, the robot is soft.
Moving from the home, back to the macro economy for a minute. What does this actually do to jobs? Musk has famously said, quote, "Working will be optional." That sounds like a post-scarcity utopia.
That is the techno-utopian view, the post-labor economics theory.
Right.
The more dystopian, or at least highly concerned view, is coming from the major labor unions. Sean Fain, the president of the UAW, the United Auto Workers, has been extremely vocal about this pivot.
What is his stance? Because the UAW just fought a massive strike a couple of years ago.
He is aggressively calling for a robot tax.
Walk me through a robot tax. How does that actually work in practice?
The union logic is pretty straightforward. If a large corporation replaces a human worker who is earning $60,000 a year with a robot, the federal and state governments lose all the income tax that human worker paid.
Plus the payroll taxes.
Right. The social safety net, Medicare, Social Security, loses its funding source.
Right.
So Fain argues the company should pay a specific tax on the robot's labor equivalent to the lost human income tax.
So it artificially slows down the adoption of robots by eroding the corporate cost savings.
It tries to level the playing field. But frankly, if the Chinese robot only costs $13,000 up front, even with a heavy tax applied, it might still be drastically cheaper than paying the human.
It's a very valid economic fear, though, especially with what we called brownfield applications earlier.
Right, we touched on this with the BMW plant. Brownfield means putting new robots into existing, messy factories designed entirely for humans.
With the stairs and the narrow aisle?
Exactly. You don't need to spend billions to rebuild the factory for modern automation anymore. The robot just walks in the front door and takes the exact spot at the assembly line the human used to stand at.
That drastically lowers the barrier to replacing a worker.
Significantly. In the past, heavy automation required building a brand new facility. Now it just requires a simple purchase order for 10 robots.
So we have covered the rapidly evolving tech, the major players, the brutal economics, and the societal fears. Let's try to summarize the key takeaways from this deep dive for you listening.
I think there are three main pillars to take away from all these sources today. First, we have officially crossed the line from prototype to real product in early 2026. This is the year humanoid robots became real manufactured goods.
Second, Tesla is literally betting the farm. They killed the car that made them famous, the Model S, just to become a dedicated robotics company. They burn their own boats.
And third, the AI brain is finally catching up to the hardware body. Thanks to massive video training and end-to-end neural networks, the AI is finally smart enough to actually utilize the physical hardware dexterity they've built.
And the so what for you? Why should you care if you aren't running a massive logistics factory?
Because of the accelerating price curve. With Unitree at $16,000 and Tesla targeting $20,000, we are rapidly approaching the cost of a used Honda Civic.
Yeah.
This technology is absolutely not staying confined in the factory. At that price point, it becomes highly accessible to small businesses, local construction sites, and eventually everyday households.
It is going to be everywhere.
It's the iPhone moment for physical human labor.
That is a truly staggering thought. A highly capable humanoid robot for the price of a used car.
It fundamentally changes the value equation of physical labor entirely.
I want to leave you with a final, somewhat provocative thought to mull over. We talked deeply about how Tesla trains these robots. They literally just watch YouTube videos. They watch humans doing things.
Right. They visually absorb our behavior and physics.
If Tesla and these other companies succeed in creating robots that can learn any physical task simply by watching a video of it, what happens to the inherent value of human skill?
It's a great question.
Because we aren't just automating raw physical strength anymore. We aren't just automating move this heavy box from point A to point B. We are automating the actual ability to learn dexterity.
That is the profound philosophical shift here. We always comfortably thought that human creativity and complex physical dexterity were our permanent moat against the machines.
Exactly. If a robot can quietly watch a master surgeon and instantly learn to stitch a wound, Or watch a Michelin star cook and learn to perfectly chop an onion. Or watch a master carpenter and learn to frame a wall.
Right.
Where does the human advantage retreat to next? We used to confidently say, robots can't do nimble things. Now they can. We used to say, robots can't learn new tricks easily without a programmer. Now they can.
It forces society to entirely redefine what it actually means to be a skilled worker. It might mean that real skill becomes solely about empathy, human judgment, and high-level strategy, rather than the physical movement of our hands.
It certainly does. And on that slightly existential note, we will wrap up this deep dive.
It's a brave new world out there.
Thanks for listening. We'll see you in the future.